Welcome. Our deep dive today is really about bridging the past and the future. We're looking at one specific product, the Thor broadcast F-1V2A-1D-TxRx.
Which is a bit of a mouthful.
It is, yeah. But what it does is solve this huge infrastructure problem.
Mm.
How do you get these old legacy analog signals, video, audio, even data across massive fiber optic networks?
And that's the core of it. You have to understand the fundamental limit of the old tech. Sending something like, say, analog composite video CVBS or good audio over copper wire just isn't practical.
It just degrades too fast.
It does. After about 100 feet, you're in real trouble. So a product like this gives a high-quality lift to existing systems without forcing a complete and very expensive overhaul.
Exactly. And the signals it handles tell you everything about its purpose. We're talking CVBS, which is that classic combined signal, plus analog audio, and even RS-485 serial data.
So things like old security cameras, VCRs, DVD players, stuff that's still critical in some places.
Right. So if copper fails at 100 feet, what is the actual long-distance solution? What does it look like physically?
Well, it's a two-part kit, a transmitter, or TX, which you put by the signal source.
And a receiver, the RX, at the destination. And they both just run on simple 12-volt DC power.
Right. Plug and play.
But why the two separate boxes? Is the conversion process that complicated?
It's all about ensuring optimal isolation. You want to maintain what they call broadcast quality, and you do that by physically separating the often noisy analog input from the very precise optical output.
Okay, that makes sense. And the connectors seem to back that up. You've got a BNC 75 ohm for video.
Which means it drops right into an existing NTSC, PLL, or CCAM setup, no adapters, no fuss.
But then for the audio and data, it switches to terminal blocks, not, consumer RCA jacks. Isn't that a bit more complex for installation?
It is, but the terminal block is there for maximum reliability. You're talking about fixed industrial installations.
So you want a permanent, secure connection.
Exactly. Especially for that control data, the RS-485 protocol. That's what you use for remote command.
What kind of commands?
Think of a distant PTZ, camera pan, tilt, zoom. You can send those commands right down the line at up to about 115 kilobits per second.
That's a huge operational advantage. Now let's get into the performance numbers, because that broadcast quality claim is a big one.
It is.
The spec sheet says the video is 10-bit digitally encoded with a 10 megahertz bandwidth.
And that's what preserves the fidelity over these extreme distances. The audio conversion is just as robust. We're talking 24-bit digitized audio at a 48 kilohertz sample rate.
Which gives you a signal-to-noise ratio better than HDTV. That's very clean.
Incredibly clean. And it's that level of quality that allows a standard unit to push a signal 20 kilometers.
With some long-haul versions hitting, 120 kilometers?
Massive 120 kilometers on single-mode fiber, yeah.
And if you dig into the more niche applications, there's a little detail that really stands out. It pulls this out of just simple surveillance.
You're talking about the sync pulses.
Exactly. It explicitly supports transmitting tri-level sync pulses, often called a CVBS black burst.
Which is a very precise timing signal.
Okay, so wait. Why is it so critical to maintain that exact timing pulse over, say, 120 kilometers?
Because that guarantees all your connected professional gear, your video switchers, your recorders, they all remain perfectly frame-locked no matter how far apart they are.
So it's about system-wide stability.
Critical stability. And that's backed up by the MTBF, the mean time between failures, which is rated at over 100,000 hours. This stuff is built to last.
So what this means for you, the listener, is that we have this incredibly reliable, high-quality solution. It means that big institutions don't have to rip and replace their entire legacy systems just because they need a modern long-distance link.
The core value is really about keeping that critical infrastructure running with existing hardware while still getting all the benefits of modern fiber.
And that leaves us with a final provocative thought for you. If these massive industrial security and broadcast systems still depend on a specialized product like this to convert supposedly obsolete signals like CVBS and RS-485 with such high fidelity over 120 kilometers, how truly indispensable are these old analog formats to the backbone of our modern infrastructure? It really suggests their final retirement might still be decades away.